All right, this is Mr. Gilman. Today we're going to start talking about inequalities. Now, I know you've done inequalities in the past, but it might have been a while. We've talked about expressions and equations, and now we're going to talk about inequalities. An expression has no equal sign. An equation does have an equal sign. And now finally, an inequality doesn't have an equal sign, but it's very similar to an equation, in that it is an equation with, instead of an equals, it's replaced with a less than or equal to, a greater than, or a greater than or equal to. So that's what an inequality is. It looks like an equation, except for instead of equals, it says one of these signs. And so let's just do a quick review on what each sign means. This is a less than sign. So 2 is less than 5. Okay. This is a less than or equal to. It has to be less than or equal to. So 2 is less than or equal to 2 would be fine, or 2 is less than or equal to 5 would work as well. Okay, so these are okay if it's the same number on both sides when it says equal. This is a greater than sign. You might have something like 4 is greater than 2. And this is a greater than or equal to sign. And you could have like 4 is greater than or equal to 4, or you could have, like I said, 4 is greater than or equal to 2. That would be true as well. So the only difference between a less than and a less than or equal to is that 2 is not less than 2, but 2 is less than or equal to 2. So that wouldn't work for this one, but it would work for this one. Same way here, 4 is greater than 2, and 4 is greater than or equal to 4, but 4 is not greater than 4. That wouldn't make sense. So that's the one difference. We include that one more number in the equal to. Okay? And I want to just keep this in mind because this is the first time we really talked about greater than or less than with inequalities and negative numbers. Any positive number is always bigger than any negative number. So 3 is going to always be bigger than negative 5. Okay? No matter what, I know the number 3 is less than the number 5, but keep in mind that negative is telling me that it's smaller. It's on the left side of 0. So when you think about these, if here's 0 and here's negative 5, I want you to keep in mind the smaller numbers are on the left and the bigger numbers are on the right. So just keep that in mind. Any positive number is always bigger than a negative number. Same way, any negative number is smaller than any positive number. Okay, so just keep that in mind. Now, because we have inequalities, that changes what our solutions are going to be. We've solved equations in the past when we found x equals 2 or x equals 3. Well, now, instead of just having one answer, there's a lot of different answers. Okay, because if I was comparing 2 to all these numbers, it'd be bigger than 1, it'd be bigger than 0, it'd be bigger than negative 1, negative 2, and I could go on forever. So with an inequality, there's an unlimited number of answers that the variable could be. So what we have to do is we have to represent it somehow. And what we do is we represent it with a diagram called a number line. Okay, so when we work with inequalities, we use a number line to show our solution. And that's because there's more than one answer, okay? And it's actually kind of a pattern. Let me take a look here. When we use a number line to show our solutions, there's a couple rules we need to keep in mind. Okay, if it's a less than or equal to or greater than or equal to, we have a closed circle. Okay, so remember now this is including the number that we're talking about. So in this case, I have a closed circle on 2. And the arrow going to the right. This would represent all the values that we don't know that are bigger than or equal to 2. If it's a less than or a greater than sign, we have an open circle. Okay, so in this case, we're talking about all the values bigger than 2 that the variable could be, but we're not including 2. It's going to be an open dot. Okay, see how it's open? So these symbols get open dots, these symbols get closed dots. The difference between an open and closed circle is that a closed circle includes the number, and an open circle does not. Okay, so my solution here I am including 2 because 2 is greater than or equal to 2. My solution here I'm not including 2 because 2 is not greater than 2. Okay. Filling in the circle, like I said here, this is kind of a repeat question. Filling in the circle, the number is included. All right, number is included. I guess what we could add to this top question would be a closed circle also gets the little bar underneath the inequality, and the open circle does not. It's just a greater than or a less than. Okay, so that's really the big point, I guess, to keep in mind. Take a look at some examples now. We're going to graph these, and the first thing I want to do is I just want to look at each one. I want to say whether it's an open circle or closed circle. So number 1, I see this bar underneath. I'm going to say that's a closed. I see number 3, there's a bar underneath. That's going to be a closed circle. I see on this one, it's going to be an open circle because there's no bar. And on this one, there's no bar, so it will be open. So when we're graphing these and we come to our solution of x has to be less than or equal to 2, we look at our number line because there's a lot of different numbers I could plug in that are less than or equal to 2. 1 is less than or equal to 2. 0 is. -1 is. -2 is. And -3 is. And I could keep going forever and ever and ever. And I could even throw decimals in there, anything in between. It doesn't have to just be a whole number or an integer. It could be, -1.1 is less than or equal to 2. -1.11, -1.111. And so I have infinitely many different decimals that are also less than or equal to 2. And so to kind of navigate around having to write infinitely many numbers down on my paper, we're going to graph it to show all the solutions. So I am including 2 this time, so I'm going to put a closed dot on 2. And this is saying what values are less than or equal to 2. Well, like we were talking about, as the number line goes to the left, it gets smaller, and to the right, it gets bigger. And we're looking for the numbers that are getting smaller. Or if you're not sure, if that doesn't make sense, we can always check, is 1 less than or equal to 2? Yes, it is. Is 3 less than or equal to 2? No, it's not. So we want to shade the side with 1, like that. We want to make sure our error is continuous because, like I said, it does keep going smaller and smaller and smaller. I never run out of answers. So I need to have this arrow on the end of my shaded part. And so there's my -1.11s in here, all my negative decimals, they're all included. All these are represented by anything this line touches will be a solution to number 1. With number 2, it's almost exactly the same, except for in this case, we don't want to include -4 because -4 itself is not less than -4. But anything right next to -4 is one way or the other. So let's think about this. Which way should we shade? In this case, once again, it's less than, and we remember that, okay, this way it gets smaller and this way it gets bigger. And we're talking about a less than sign. We need to go to the left. Or if you're still not sure about that, just check to see which side we should go to. Is -5, which is on the left side, less than -4 if I plug it in for x? Yes, it is. Is -3 less than -4? No, it's not. -3 is on the bigger side of -4. So I'm going to shade all my solutions over here. Make sure my arrow is continuous. It's going to the left. My less than arrows will move to the left. Always, always, always. And that'll represent all of our solutions. My greater than or equal to, I am including 3 because I know that 3 is greater than or equal to 3. So I'm going to put a closed dot and include it. I'm looking for the values that are bigger than 3, so let's just check. I know it's going to go to the right because I know the numbers get bigger when they go to the right and smaller when they go to the left. And we're talking about the numbers that are getting bigger. But just to be safe, let's check. Is 2 greater than or equal to 3? No, it's not. Is 4 greater than or equal to 3? Yes, it is. So I want to shade the side with the 4. Okay, and like I said, this number line itself is actually indicating all the different possibilities. It includes 5.5, it includes 4.5, 3.5, 3.1, 3.2. All these little decimals in between are included because the line is touching them. All right, and then finally we have x is greater than 0. Once again, I'm going to start with an open dot because 0 is not greater than 0. That's not a true statement, so I don't want to include this, but it's the closest thing that I can get to. Now I know that all the numbers that get bigger go to the right. To the right they get bigger, to the left they get smaller, and this time we're looking for the numbers that are bigger than 0. If that doesn't make sense, check to see. Is 1 bigger than 0? Yes, it is, so that's the side I want to put my line on. Is -1 less than 0 or greater than 0? No, it's not. So I know I need to go to the right, and that's going to represent all my solutions, so I don't have to write all infinitely many of them down. And this arrow is important because that represents that there's more lower on the number line that are also going to be solutions. Finally, we're going to apply this to what we know about equations. All right, when we're solving these inequalities, you do it the same exact way as an equation. So this is just a two-step equation, but instead of an equal sign, we see an inequality. So I'm going to solve it the same way. It's just a two-step equation. I want to get the variable all by itself. Isolated is what they call it. So I want to add or subtract first to help me. I see a subtraction of 8, so addition is what I want to do. And then I will have no constants left. Just have my 2x. And now instead of an equal sign, it's a less than or equal to. It's going to stay the same all the way down until we learn about a new rule tomorrow. Negative 8 plus 8 is 0. Now I have 2 times x, so I will divide by 2. X must be less than or equal to 0. All right, now there's a lot of different numbers that x could be that are less than or equal to 0. So we're going to represent the solution by a graph. We're going to say 0 is less than or equal to 0. So we're going to include him with a closed dot. And I want the numbers that are smaller than or equal to 0. So in this case, negative 1 would be less than or equal to 0. Let's shade towards the negative 1. Or you can remember that the smaller numbers go to the left and the bigger numbers go to the right. So my solution is represented by this number line. It includes all the decimals, all the fractions, anything on that side of 0, it is including because those will all be solutions to this equation. Again, we have this equation. It's a two-stepper, and we're getting pretty good at them, so I think I'm going to go ahead and just save you a little bit of time here and go ahead and work through it. So we're getting closer to the solution. I saw addition, the inverse is subtraction. And now I'm going to do division because I see that 3 times x I want to undo. So x must be greater than or equal to 3. Notice how I didn't change the sign. It stayed the same, and I just use that as my new equal sign. Okay, the same steps apply. So in this case, I'm going to go to 3. I'm going to use the closed dot again because I want to include 3 because I know 3 is greater than or equal to 3. And now if you're not sure which side to graph, once again, there's the positives and there's the negatives. It gets bigger to the right, smaller to the left, and I want the numbers bigger, so I'm going to go to the right. If you're not sure about that, just check to see, is 4 greater than or equal to 3? Yes, it is. So we are good to go. I don't know why my marker is doing that. Yes, it is. Okay, so we go to the right. So we have just one more to do, and plenty of time to do it. Once again, this time what I notice is it's going to be a open dot and open dot. So I'm going to use inverse operations again. 1/2 x is less than negative 8 plus 6, negative 2. And now here's a part that I've noticed on some papers that I'm still not agreeing with. I'm seeing a lot of people say, well, since it's 1/2 times x, I need to divide both sides by 1/2. Yeah, we're going to start losing points for doing that. That is not appropriate. That's not how Mr. Gillum wants you to do your fractions. Okay, it's going to be very confusing. Mr. Gillum has taught you how to multiply fractions. And so strategically, if I can cancel out the 1 and the 2 and be left just with x, that's what I'd like to do. And I know through multiplication, if I multiply by 2 over 1, everything will cancel out. So I'm going to multiply this side by 2 over 1 as well. So instead of dividing by a fraction and getting a complex fraction, multiply both sides by the reciprocal, please. And we've talked about this several times in class, and it's just not sticking. We need to know how to do this. This is a very important skill for next year. X is less than negative 2 times 2, negative 4. So in this case, we're going to an open dot, and we want the values less than negative 4 to the left. If you're not convinced, you can always plug in negative 5. Is that less than negative 4? Yes, it is. Is negative 3 less than negative 4? No, it's not. So we did shade the side with the solutions. That's what the arrow represents, is where the solutions are. So that's it for today.